Today we're starting Unit 6, Section 1, Intro to Polynomials. I'm going to try to make this as simple as possible, straight to the point, and go to what matters. So, what is a polynomial? So, don't mind all these math things, they're just there to intimidate you. So, here's what really matters. The good rule of thumb for determining what a polynomial is that a variable's exponent must be a whole number. So if you have a fraction or a negative exponent, that's a no-no, that's not a polynomial. There cannot be a variable in the denominator of a fraction. There cannot be a variable under the radical. Okay, what it looks like is we're going to practice by circling or identifying those that are not polynomials. And we're going to follow these three rule of thumbs right there. So the first one is already not a polynomial because it has the radical right there it has the variable right there under the radical. So this one is not a polynomial because it has a variable under the radical. This one, all the variables are whole numbers. 4 right there, 3 right there, and invisible 1 right there. So this one, yep, polynomial right here. This one, it is not. Why not? Because it has a variable right there in the denominator of a fraction. Variable denominator of a fraction. So variable in the denominator. This one, you have a variable on the exponent. That's a no-go because the variables on the exponents must be whole numbers. No fractions, no negatives, no variables. So you have a variable in the exponent. Okay, this one is nice and pretty, just whole numbers on the exponent. This one, again, nice and pretty, just invisible 1. Oh, this one, even though you have a whole number right there, but there's a negative exponent, and it says it can't be. Okay, so this one is not a polynomial because you have a negative exponent. This one is nice and pretty, all whole numbers. This one is nice and pretty. Just watch out that this negative belongs to the variable. That does not belong to the exponent. So don't fall for this one. And this one is not a polynomial because of this guy right here. You have a fraction on the exponent. Okay. Next, we have the parts of a polynomial function. So a couple things we need to know is the degree of a polynomial. Is the highest degree of the polynomial in standard form. So a couple things you need to check. This one is the example that we're using. So notice how this is already in standard form, and it goes from highest to lowest degree. So the highest exponent is 3, exponent 2, 1, and 0 on the variable. So in this case, the degree of this polynomial will be 3. So it's the highest degree of the polynomial, okay? Degree 3. The leading coefficient would be the number multiplied by the variable in the leading term. So that will be this number right here. I'm going to use red. Leading coefficient is the number in front of the variable. That's what it's saying. The next one, we have the leading term. It's the term with the highest degree. So the term with the highest degree is that one, leading term. And it's the whole thing, negative 2x cubed. That's the leading term. The constant term is the number on its own. It's the constant. It's the number without the variable, the number without the letter. So it's this one right here in purple. And you already know that standard form is always in descending order. Okay, we're going to practice. Is this a polynomial? Well, this one is, because I don't have any letters on the exponent. All my exponents are whole numbers. I don't have any negatives on the exponent, and there's not a letter under the radical. Okay, is this in standard form? No, not yet. So let's go ahead and write this in standard form. And I don't have enough room, so I'm going to start writing right there. So we're going to write from highest exponent to least. So the highest one is x to the fourth power, and then I have 3x cubed, negative 15x squared, negative 2x. Okay, that's standard form right there. The leading coefficient, the leading term is the one that has the highest exponent. So x to the fourth power, it needs the whole term. Leading coefficient is the number in front of the highest or the leading term. In this case is 1, because you don't have anything, so it's a 1. The degree right there is 4, so you have to look at the exponent. And the constant term would be the number without the variable. And in this case, I don't have one, so it's 0. The next one, is this a polynomial? Yes, because of what we talked about there. Standard form, we need to check if it's in highest to least exponent. In this case, it's already there. So already in standard form. Leading term is the one in the front, or the one with the highest exponent right there. Leading coefficient is the number in front of the leading term, so negative 1. Degree, 7. Constant term is that 5 right there. Yes, it's a polynomial. We need to write this in standard form. Highest to least degree. The leading term is the one with the highest degree, so 3 cubed, 8x cubed. Leading coefficient is the number in front of the leading term, so 8. Degree, 3. Constant term, that one, negative 9. Polynomial, yes. Not in standard form yet. So I have f of x. Highest degree is 5, so 4x to the fifth power plus 2x cubed minus 9x squared minus 9. Okay, leading term, 4x to the fifth power. Leading coefficient is that 4 right there. Degree, that's that 5 right there. Constant term is that negative 9 right there. The last one on this page, it is a polynomial. Standard form, no, we need to put that in standard form. So 6, 5, 4, 3, 2, 1, and then the constant. Okay, leading term is 1/2 x to the 6th power. Leading coefficient is that 1/2. Degree, that's 6 right there. Constant term, that one, negative 8 right there. That's not bad. Some things that you already knew, but sometimes we just need to put names to what you already know. Now this part right here, I like to color code it. That way I don't miss anything and I don't leave anything out. So we need to combine like terms and then write the answer in final and standard form. I'm going to use a couple different colors here. Oh, I need a third color. There it is. No, just kidding. Aha. So I'm going to look for x squared. So I'm going to combine both x squared, and then I'm going to combine x, and I'm going to combine the constant. All right. Since I have a plus right there, I don't have to distribute the plus. It's just there, really. So easy. 3 plus 1 is 4. So 4x squared. 11 minus 5 is 6. So 6x. 4 minus 13 is negative 9. And it's already in standard form right there from highest to least degree. Okay, number 2. Again, I have a plus right there in between them, so I don't really have to go one more step and distribute that plus. So it's already halfway solved for us. Okay, let's do p cubed. There's not another one. P squared. I have p and the constant. So 9p cubed. Negative 4 minus 2 is negative 6. P squared. 2 plus 1 is 3. P. Negative 10 and 7 is negative 3. Already in standard form. Now, this negative, I have to deal with it before I start grouping, before I start combining like terms. So 3x squared plus 11x plus 4, distribute the negative right there with all these guys. So 2 negatives make a positive. Minus x squared plus 13. Now I'm going to sort them out. So x squared, x, and the constant. So positive 3 minus 1 is 2x squared. 11 and 5 is 16x. 4 and 13 is 17. Number 4 right there. Again, I have to distribute that negative, just like what we did in number 3. So negative 2k squared minus 2k minus 17. I don't have another k cubed. I have k squared. I have k. And I also have, this is the only constant, so I don't have to combine that with anybody else. So 5k cubed, negative 2 minus 2 is negative 4. 2 minus 2 is 0, so I have 0k, and I'm not going to even write any k because I have 0k minus 17. Again, it's already in standard form. Distribute the negative. So negative 1 minus 2y squared. 2 negatives make a positive right there, so plus 5y plus y cubed. This is the only y cubed, so I'm not grouping that with anybody. I have y squared. I have y. And I have 2 constants right there. All right. So y cubed. Y squared, I have 4 minus 2 is 2. Y squared. 1 and 5 is 6. And then constant is negative 4. So negative 3 minus 1 is negative 4. One more in this page. So this one I have to subtract this one from that one. what does that look like? If I have to subtract this one from this one, so I have 8b squared plus ab minus 2a squared. Subtract that from this, so minus negative 10ab plus 7a squared minus b squared. That's what the question is telling us to do. So distribute the negative. So two negatives make a positive. So now I have b squared with b squared. I don't have another b squared. How about a squared, a squared? And I also have ab, ab, ab. All right, in order for something to be like terms, they have to have the same letter, the same exponent. Same letter, same exponent, letter with the same exponent. And then you think, okay, how am I gonna put this in standard form if they both have, all three of them really, they have the same degree? I like to do this in alphabetical order, but there's not a right and wrong way to do it. They say you have to put that in order from highest to least degree. And since they all have the same, you do it as you please. So again, I like to do that in alphabetical order. So I'm going to do a squared first. So negative 2 minus 7 is negative 9a squared. And then I'm going to do b. 8 plus 1 is 9, 9b squared. And then finally ab together. It could be in the middle. It doesn't really matter. So AB is 1 plus 10 is 11. So plus 11 AB. And I'll make a separate video for page 4.